Slide your headphones on, tap a name on your screen, and within 3 seconds you are having a crystal clear, laughing conversation with your best friend who is sitting at a busy coffee shop on the complete opposite side of the planet. We do this every single day without blinking an eye. But if you actually pause and think about it for just a moment, this everyday habit is completely mind-blowing and defies all natural logic. How can the physical sound of your vocal cords vibrating in a quiet room in New York instantly reach a human eardrum in Tokyo? Your voice cannot even travel through a solid brick wall in your own house, yet it somehow crosses massive oceans, snowy mountains, and entire continents in a fraction of a second. If you have ever looked at a tiny piece of plastic sitting in your ear and wondered how it catches your voice and magically teleports it across the globe, you are in the exact right place. Today, we are going completely behind the scenes to trace the incredible high-speed journey of your voice, from the microphone in your room to the speaker in your friend's ear, so you can finally understand the invisible global highway keeping us all connected. The epic journey of your conversation begins the exact millisecond you open your mouth to speak. To understand the microphone, we first have to quickly understand what sound actually is. When you talk, sing, or laugh, your vocal cords physically vibrate, violently pushing the invisible air molecules floating in your throat and mouth. This creates a chain reaction of microscopic air pressure waves crashing into each other, acting exactly like dropping a heavy rock into a calm pond and watching the ripples spread outwards in all directions. When those invisible air ripples reach your headset, they crash into the very first piece of the technological puzzle, which is the microphone. Inside that tiny microphone is a microscopic, ultra-thin piece of material called a diaphragm. It is so incredibly thin and hypersensitive that when your invisible sound waves hit it, it physically vibrates back and forth, perfectly matching the exact rhythm and pitch of your voice. Right behind this rapidly vibrating diaphragm is a tiny, powerful magnet and a microscopic coil of copper wire. As the diaphragm physically pushes and pulls that wire back and forth through the magnetic field, a beautiful rule of physics takes over, creating a tiny, fluctuating electrical current. This is the first massive magic trick of the journey. Your microphone literally translates the physical acoustic energy of your voice into a raw electrical signal. Your voice is no longer just moving air, it has officially become pure electricity. But right here we run into a major logistical problem. Raw electrical waves cannot be shot across the ocean on their own, because analog electrical signals degrade and lose their quality over long distances. The electricity needs to be converted into a perfect, flawless language that modern computers and internet cables can actually understand and transmit without losing any detail. This is where a tiny, incredibly hardworking computer chip inside your phone or computer, called an analog to digital converter, steps in to save the day. This chip acts like an insanely fast digital translator. It takes that raw, wavy electrical current coming from your microphone and mathematically slices it into millions of tiny, discrete pieces. In a standard audio call, this chip measures the exact voltage of your electrical voice tens of thousands of times every single second. It then assigns a simple mathematical number, made entirely of zeros and ones, to every single microscopic slice of audio. In a matter of milliseconds, the warm physical sound of your laugh is completely shredded, analyzed, and perfectly rebuilt into a massive organized string of digital binary code. Your voice is now pure digital data, perfectly packaged and completely ready to travel the world at the absolute speed of light. Now that your voice is just a digital file of zeros and ones, your smartphone uses its internal antenna to blast that data through the air using invisible radio waves. These high-frequency radio waves travel at light speed straight to the nearest cellular tower in your neighborhood. From there, your voice drops out of the empty air and dives deep underground into a massive buried network of fiber optic cables. This hidden network is the actual physical backbone of the internet. These cables are made of ultra-pure flexible glass, and they carry your digitized voice not as electricity but as rapid flashing pulses of concentrated laser light. Your voice shoots across your home country in the blink of an eye, and then it dives deep under the ocean, traveling through massive, heavily armored submarine cables laying directly on the pitch-black seafloor to reach a completely different continent. It travels through thousands of miles of underwater glass cables, gets routed through massive data centers, and is finally blasted back into the air as a radio wave by the specific cell tower nearest to your friend, landing perfectly into their smartphone antenna. This entire mind-boggling global journey from your phone down to the bottom of the ocean and up into their device happens in roughly 150 milliseconds. It is so incredibly fast that your brain does not even notice a delay in the natural flow of the conversation. But the journey is not quite over yet, because your friend cannot hear zeros and ones, and their brain certainly cannot understand flashing laser light. The entire technological process has to be completely reversed in real time. When their phone receives that digital data packet, an internal chip called a digital to analog converter translates those zeros and ones straight back into a raw wavy electrical current. This newly formed electricity is sent directly up the headphone wire, or transmitted wirelessly via Bluetooth, straight into the earpieces sitting on their head. Inside the ear cup of the headphones sits the final brilliant piece of engineering, which is the speaker driver. A speaker is essentially just a microphone working in absolute reverse. It contains a permanent magnet, a suspended coil of wire, and a thin, flexible plastic or paper cone. When that fluctuating electrical current flows into the coil, it reacts violently with the permanent magnet, causing the entire coil to physically push and pull away from the magnet. Because the coil is glued directly to the thin cone, the cone is forced to violently punch the air in front of it, moving back and forth thousands of times a second. This rapid mechanical punching creates physical air pressure ripples that perfectly, flawlessly match the original air ripples you made with your vocal cords thousands of miles away. These newly created air ripples travel a fraction of an inch straight into your friend's ear canal, vibrating their eardrum, and allowing their brain to hear your exact voice with perfect clarity. It is an absolute masterpiece of modern physics, electrical engineering, and global infrastructure. Every single time you just casually say hello into your headset, your voice is transformed into raw electricity, mathematically shredded into digital data, shot as a flashing laser beam across the bottom of the ocean, turned back into electricity, and used to physically punch the air inside someone else's ear, all happening in the literal blink of an eye. We take it completely for granted as we go about our busy days, but this complex, high-speed, invisible translation is the absolute only reason we can maintain long-distance relationships, conduct global business, and stay close to the people we love the most, no matter how many physical miles stand between us. If this breakdown helped you finally appreciate the incredible, world-changing technology sitting right there on your desk, hit that subscribe button, give this video a quick thumbs up, and leave a comment below telling me the absolute furthest place on Earth you have ever called. Thanks so much for watching, and stay connected.